Good morning everyone. Hope you all are fine at home. Today we will discuss another question of exercise 2.2, that is question number 8 and part is 7. This is question number 8, 7 part. So in this our statement is sine inverse 4 by 5 plus cos inverse 2 by root 5 is equal to cot inverse 2 by 11. First thing, we have to use the conversion property because we have to prove left side is equal to right side. So first you have to apply the conversion property to convert this either this as sine inverse or this sine inverse as cos inverse. So better I go with cos inverse, then I can apply the formula directly, cos inverse x plus cos inverse y. So for that, a conversion property. So what should I do? First what I will do here, so I want to convert this sine inverse 4 by 5 into cos inverse. So I go with right angle triangle first. So if I have this right angle triangle, so if I consider this whole term as x, so this is my angle x and this is 4 by 5, that is perpendicular upon hypotenuse. So that means this is my 4, this is my 5, and here my triangle is A, B and C. Now next target is, first I have to find this that is base from by Pythagoras theorem. So we consider here, let sine inverse 4 by 5 is equal to x, 4 by 5 is equal to sine x. So that is perpendicular upon hypotenuse. Now I apply this Pythagoras theorem formula. Then according to Pythagoras theorem, so when I apply it here, so that is AC square is equal to AB square plus BC square. Now AC square is 5 square, AB square I have to find, and BC square is 4 square. So AB square is equal to 5 square is 25 minus 16, 5 square is 25 and 4 square is 16. So I shift this term on this side, so I will write in this way. So that is AB square is equal to 9. So if I want to find the EB value, so that will be root of 9 is equal to 3. So we took the positive value here because we are going to measure the distance, otherwise it will be plus minus 3. Now we'll go with the cos x. Cos x is, if I found this value as 3, cos x is base upon hypotenuse, that is base upon hypotenuse, that is 3 upon 5. So now when you shift cos on this side, my x value will be cos inverse 3 by 5. That means this sine inverse 4 by 5 equivalent to cos inverse 3 by 5. Now I replace the value this in my left hand side, which I want to prove cot inverse 2 by 11. So when I pick here left hand side here, so sine inverse 4 by 5 changes to cos inverse 3 by 5 plus cos inverse 2 by root 5. Now here I have a formula. So that is cos inverse x plus cos inverse y is equal to cos inverse xy, root minus is there, and root 1 minus x square and 1 minus y square. So I am going to use this formula in place of this cos inverse x plus cos inverse y. So x is 3 by 5 and y is 2 by root 5. So when I apply the formula here, so what will be my condition? So in place of x there is 3 by 5 and in place of y is there is 2 by root 5. So how I will write the formula? That cos inverse 3 by 5 into 2 by root 5 minus, then 1 minus x square. In place of x there is 3 by 5. 1 minus 3 by 5 whole square root, and 1 minus y square. In place of y there is 2 by root 5 whole square. Now you have to go further. So this is cos inverse. So when you solve this one, this gives you 6 by 5 root 5 minus 1 minus 9 by 25 here, and here 1 minus 4 by 5. Now I will take the LCM here. So that is cos inverse 6 by 5 root 5 minus 25 minus 9 by 25 root, and here 5 minus 4 by 5. So what I will do next here, so cos inverse 6 by 5 root 5 minus 16 by 25 square root and 1 by 5. Okay, so this I will cancel the square root here, so that give me 6 by 5 root 5. Here is 4 by 5 root 5. Okay, now here denominator is same, so I will go further. I will take the LCM. So that is 5 root 5 and 6 minus 4. So that give me cos inverse 2 by 5 root 5. Okay, but now my question is that I want to prove that cot inverse 2 by 11. That means whatever value I get it here cos inverse, now I try to convert into cot inverse. So I go again with the right angle triangle. So here again A, B and C. So if this is my angle x and cos inverse is based upon hypotenuse, that means this is base and this is height. So I go with the Pythagoras theorem here. AC square is equal to AP square plus BC square. So my AC value is 5 root 5 whole square, AB is equal to 2 square, and BC square I have to find. So 5 square is 25, 25 into 5 is 125 minus 4 is equal to BC square. So that give me, if you subtract this one, 5 minus 4 is 11, 121 is equal to BC square. So that means square root of 121 is equal to BC when we are going to measure the distance. So that will be, we take as positive. So BC is equal to 11 because square root of 121 is 11. So we find this side. So now we can easily convert into the cot form. Then if cos inverse is this, so if we consider this as cos inverse 2 by 5 root 5 is equal to x, 2 by 5 root 5 is equal to cos x. Okay, so that become based upon hypotenuse. So now you have to go with the cot x. So cot x is equal to base upon perpendicular. So that is 2 by 11. When you move here, so that x is equal to cot inverse 2 by 11. So that means cos inverse 2 by 5 root 5 is equal to x is equal to cot inverse 2 by 11. So if you replace this one, because this is your middle part, okay, now if you replace this one as cot inverse 2 by 11, so that is exactly equal your right hand side.